It was past midnight when the Catalina Sky survey computers flagged something unusual. A new detection, a large signature, a trajectory incoming. Dr. Sarah Chen pulled up the data, ran the orbital calculations twice, then reached for her phone to call JPL. The asteroid was bigger than expected and following a path that demanded immediate attention. That discovery kicked off what's become the most intensive asteroid monitoring year in recent history. NASA is currently tracking 34 asteroids approaching Earth in 2025. 3 have astronomers particularly concerned, potentially hazardous objects requiring constant monitoring. Here's the thing about modern asteroid detection. We can predict these encounters with 99.9% accuracy. We know exactly when they're coming and exactly how close they'll get. That remaining 0.1% uncertainty, that's what keeps planetary defense experts awake at night and might as well do the same to you. Keep watching. Let's start with something that happened while most of the world was completely oblivious. On what seemed like an ordinary day in 2025, an asteroid designated 2025b P6, roughly the size of a small car, screamed past Earth at just 3,300 kilometers above our surface. To put that distance in perspective, that's closer than the International Space Station orbits. This space rock, measuring between 1.1 and 2.6 meters in diameter, came closer to Earth than most people will ever travel from their hometown. Yet almost nobody knew it was happening. This wasn't a near miss that had astronomers holding their breath. It was just another Tuesday in our solar system. But it perfectly illustrates why the question, what asteroids might hit Earth in 2025, is more complex than it appears. 2025 BP6 technically could have hit Earth if its trajectory had been slightly different. But the reality is that even if it had been on a collision course, it would have burned up spectacularly in our atmosphere, creating nothing more than a brilliant fireball. Then there was 2025 KF, which earned the dramatic title of house-size asteroid from the astronomers tracking its approach. This space rock passed within 1/3 of the Earth-Moon distance on May 21st, 2025, approximately 128,000 kilometers away. Now, 128,000 kilometers might sound like a safe distance, but in cosmic terms, that's practically brushing shoulders with us. To put this in perspective, if Earth were a basketball, this asteroid would have passed by at a distance equivalent to about 3 basketballs lined up end to end. In space, that's uncomfortably close. What makes encounters like 2025 KF particularly interesting for the might hit Earth question is that these asteroids follow chaotic trajectories. Unlike planets with their predictable orbits, asteroids are influenced by gravitational tugs from multiple bodies: the Sun, Earth, Moon, even Jupiter. Each encounter with Earth slightly alters their path, meaning that while 2025 KF posed no threat during its May passage, its future trajectory has been subtly modified by our planet's gravity. Here's where things get mathematically fascinating. Throughout 2025, dozens of asteroids have made what astronomers call close approaches to Earth. NASA's Asteroid Watch dashboard tracks these encounters continuously, and the frequency might surprise you. We are talking about multiple close approaches every single month. But we are really asking about probability calculations that exist in a realm between certainty and impossibility. Every asteroid that passes close to Earth has a non-zero probability of impact. But for most of 2025's visitors, that probability is so astronomically small that it's essentially zero. The asteroids that did approach Earth in 2025 fell into several categories. Tiny objects like 2025 BP6 that would burn up in our atmosphere, even on direct collision courses. Larger objects like 2025 KF that passed at safe distances but demonstrated how active our cosmic neighborhood really is. And then there are the ones that briefly had astronomers doing more serious calculations. The challenge of identifying asteroids that might hit Earth in 2025 begins with a fundamental problem. Asteroids are essentially invisible until they're very close. These are dark objects that reflect very little sunlight, making them incredibly difficult to spot against the black backdrop of space. NASA operates a network of ground-based telescopes specifically designed for asteroid hunting, scanning the sky night after night, looking for the telltale sign of a moving object, a point of light that shifts position against the background stars. But finding an asteroid is only the beginning of determining whether it might pose a threat. When astronomers discover a new near-Earth asteroid, they face a race against time. The object might only be visible for a limited period before it moves too far away or becomes too faint to track. During that window, they need to collect enough observations to calculate its orbit with sufficient precision to determine if it poses any threat to Earth. Every newly discovered asteroid goes through a process that's part detective work, part advanced mathematics. Astronomers feed their observations into sophisticated computer models that calculate not just where the asteroid is now, but where it will be months or years into the future. These calculations involve what's called orbital uncertainty, a mathematical representation of how confident scientists are about an asteroid's future path. When an asteroid is first discovered, this uncertainty can be enormous. The asteroid might be on a collision course with Earth, or it might miss us by millions of kilometers. The initial data simply isn't precise enough to tell the difference. This is why some asteroids briefly appear on potentially hazardous lists before being removed as more observations refine their orbits. It's not that scientists made mistakes, it's that they're being transparent about uncertainty while working to reduce it through additional observations. For 2025 specifically, this process played out multiple times with various newly discovered asteroids. Objects that initially appeared potentially threatening were quickly ruled out as non-hazardous once sufficient observations allowed for precise orbit determination. While no asteroids were confirmed to be on collision courses with Earth in 2025, there were several objects that briefly had astronomers running impact probability calculations. These weren't the tiny space rocks that regularly zip past us, but larger objects whose initial orbital uncertainties included Earth intersecting trajectories. The process typically unfolds like this. A new asteroid is discovered. Initial observations suggest a possible Earth encounter. Automated systems flag the object for priority tracking, and astronomers around the world coordinate follow-up observations. Within days or weeks, refined calculations usually rule out any impact threat. But during those initial periods of uncertainty, these asteroids technically might hit Earth based on the available data. The probability might be small, perhaps 1 in 10,000 or 1 in 100,000, but it's mathematically non-zero until additional observations either confirm or rule out the threat. When asteroids reach certain risk thresholds, even temporarily, they trigger protocols developed by the International Asteroid Warning Network. This coordination system ensures that potentially threatening objects receive immediate attention from observatories worldwide. The network represents something unprecedented in human history: international cooperation, specifically designed to protect our planet from cosmic threats. When an asteroid might hit Earth, even with very low probability, information sharing between countries becomes automatic, transcending political boundaries, in recognition that asteroid impacts affect everyone. During 2025, this network activated several times for asteroids that initially appeared potentially hazardous. While none of these alerts resulted in confirmed threats, they demonstrated that our planetary defense systems are functioning exactly as designed, identifying potential dangers early and coordinating the international response needed to assess them properly. So the question of which asteroids might hit Earth in 2025 can only be answered because of remarkable advances in detection technology. Modern asteroid surveys can spot objects just a few meters across when they're still millions of kilometers away, a capability that would have seemed impossible just decades ago. The process begins with automated telescopes that photograph the same patches of sky repeatedly throughout the night. Computer algorithms then analyze these images, looking for objects that move against the background stars. When a moving object is detected, the system automatically alerts astronomers for follow-up observation. But detection is only the first step. Determining whether a newly discovered asteroid might hit Earth requires precise measurements of its position over time. These observations allow astronomers to calculate the asteroid's orbit, its path through space, and its position at any future date. Here's where the mathematics of asteroid tracking becomes fascinating and frustrating in equal measure. Every orbital calculation comes with uncertainty ranges that depend on the quality and quantity of observations. For newly discovered asteroids, these uncertainties can be enormous. Imagine trying to predict where a baseball will land after someone throws it, but you can only observe the first few inches of its flight path. That's essentially what astronomers face when calculating long-term asteroid trajectories based on limited observations. This uncertainty is why the list of asteroids that might hit Earth in 2025 changed throughout the year. Objects that initially appeared potentially threatening were removed from concern as additional observations narrowed their orbital uncertainties and ruled out Earth-intersecting paths. There's something about the threat of space rocks that awakens ancient fears in all of us. We're naturally drawn to catastrophic scenarios, even when their probability is vanishingly small. This psychological tendency explains why asteroid stories generate such intense public interest and media coverage. But our fear of asteroid impacts is both justified and completely out of proportion simultaneously. Justified because large asteroid impacts can cause genuine devastation. The dinosaur-killing impact 66 million years ago proves that. Out of proportion because the probability of such events occurring in any given year, including 2025, is extraordinarily small. The challenge for both scientists and the public is maintaining appropriate perspective. Yes, asteroid impacts happen. Yes, we should take the threat seriously enough to develop detection and deflection capabilities. But no, we shouldn't lose sleep over the possibility that an undetected asteroid might hit Earth tomorrow. Every asteroid that briefly appears on potentially hazardous object lists becomes fodder for dramatic headlines. Asteroid could hit Earth generates more clicks than asteroid will probably miss Earth by millions of kilometers after we get better observations. This media tendency means that the public perception of asteroid threats often becomes disconnected from the actual mathematical probabilities involved. An asteroid with a 0.01% chance of Earth impact, essentially zero, might generate worldwide headlines about potential catastrophe. The result is a persistent cycle where newly discovered asteroids create brief periods of public concern before being ruled out as non-threatening. Understanding this cycle is crucial for interpreting news about asteroids that might hit Earth in any given year. From an asteroid perspective, 2025 was actually a relatively quiet year. No large asteroids were predicted to make extremely close approaches, no objects were confirmed on collision courses, and no genuine impact threats materialized. But quiet in asteroid terms doesn't mean inactive. The dozens of close approaches throughout 2025 demonstrated that our solar system is a dynamic, busy place. Each encounter provided valuable scientific data and tested our detection and tracking capabilities. The final verdict on asteroids threatening Earth in 2025. None actually hit us, though dozens swept dangerously close, triggering intensive monitoring campaigns before scientists confirmed we were safe. Here's the fascinating paradox of modern asteroid defense. The better we get at detecting and tracking near-Earth objects, the more potential threats we discover. Not because space has become more dangerous, but because we're finally seeing what was always there. Every year, including 2025, brings discoveries of previously unknown asteroids that made close approaches to Earth. Some of these objects passed closer than our satellites. Others approached within the moon's orbital distance. A few briefly appeared on lists of potentially hazardous objects before being ruled out. This constant stream of discoveries creates the impression that asteroid threats are increasing, when in reality, we're simply becoming aware of the cosmic environment that has always existed around Earth. No asteroids hit Earth in 2025, but dozens passed dangerously close. We've built unprecedented detection systems that spot threats years ahead and deflection technologies that could save our planet. The age of cosmic surprise attacks is over. We're watching the skies. Smash that like and subscribe button if you want to stay ahead of the next cosmic threat, because space doesn't wait for anyone.